All right, class, I've given you 2 take-home problems to do. And even though you're home right now, they're in-home problem, I guess I should call them. All right, hopefully you did it. Let's go over them to make sure you get these down. So the first one was phosphoric acid plus calcium chloride. So we have 2 ionic compounds because, again, remember, acid and bases are technically under ionic compound. And one thing I want to emphasize again, when you have an ionic compound, what's going to happen is you usually have the metal first and then you have the non-metal. That's really key. You have the cation and you have an anion. And the other thing I need you to remember when you have ionic compound is that ionic compound, what you have to do is a balance of charges. Balancing charges is really key for ionic compound. Balancing charges is very key for ionic compound. Okay, so double replacement reaction, they are going to switch partners. Hopefully you got this part down. Okay, they're going to switch partners. What that means is hydrogen is going to leave phosphorus and is going to go and hang out with Cl. Okay, so because of that, I'm going to write over here, I'm going to write H and then I'm going to write the Cl. So far, so good. Now, again, remember, ionic compound, because it's a metal first and a non-metal, is a plus and a minus, and you have to balance charges. You always have to be balancing the charges. Don't forget it. It's a balancing of charges. Okay. Now, hydrogen has a charge of +1 in a group 1A. Cl has a charge of -1. It's in a halogen group. So, is this balanced? This is already balanced. So, we are good. Now, plus, phosphate is going to leave hydrogen, go and hang out with calcium. But we have to write the calcium first because calcium is a metal. You write the metal plus first and then you write the non-metal. And then the phosphate is PO4. What's the charge in calcium? Group 2A is +2. What's the charge in phosphate? Is a polyatomic ion, is -3. Okay, so then what I would have to do when I cross multiply the charges, it would be calcium 3, PO4 2. Because what do I have to do? I have to balance the charges, right? You cross multiply the charges. We're good so far? Okay, now I'm going to rewrite the molecular equation. So it would be phosphoric acid plus calcium chloride goes to hydrochloric acid plus calcium phosphate. This is my molecular equation. Now don't forget, you have to balance the equation. Now, how do I balance this equation? To balance this equation, let's see, I have 3 hydrogen, I have 2 hydrogen here. I have 1 phosphate, 2 phosphate. So I'm going to put a 2 here. You have to play around with this one a little bit. So 2 phosphate, 2 phosphate. You guys are good? And remember, we talked about this. Phosphate is a polyatomic ion. So what you would have to do for polyatomic ion, you balance them as 1 unit. You should always keep the phosphate together because that's how it exists. It's a polyatomic ion. Okay, so 2 phosphate, 2 phosphate. I have 3 calcium. I'm going to add a 3 over here. So now I have 3 calcium. So 3 calcium, 3 calcium. Now I have 6 hydrogen. I have only 1 hydrogen. I also have 6 Cl. I only have 1 Cl. So I'm going to put it at 6 over here. And this equation is balanced. I've gone a little faster now because we've done these problems. Alright, now one last thing I want to mention. I just want to make sure that you guys get this completely down. How come I didn't take the 2 from here and take it to the other side? How come I take the 3 from here, take it to the other side? The reason that there is a 2 here because Cl is hanging out with calcium. And the 2 comes from calcium because calcium is +2, Cl is -1. We balance the charges. Now that Cl has left calcium and has a new partner, we have to rebalance the charges. Because this guy is not from the calcium, is from the calcium, is not from the Cl. That makes sense? Okay, the same over here. The 3 comes from phosphate. Now that hydrogen has a new partner, I have to rebalance the charges. Cl has a -1, so there is no 3 here because the 3 was here because of the phosphate, because of the balancing of charges. So the subscripts are from balancing of charges. Now, the PO4, this 4 is different because this is a polyatomic ion. This is one ion. We don't mess with that. We don't mess with that. Yeah? All right. So this is my molecular equation. We said all of these are happening in water. All of these are happening in water. So we have to look at each one to see what happens to them in water. Phosphoric acid. What happens to phosphoric acid in water? Remember, solubility rule is only for ionic compounds and bases, and not for acid. For acid, we talked about this. We said all acids are soluble, but a strong acid would completely break up in water. Weak acid, only few would break up. So for this class, we're going to keep them together. Phosphoric acid, weak acid or strong acid. That's the thing. Phosphoric acid looks really strong, but is not. It's not one of the strong acids. So it's actually a weak acid. What am I going to do for this class? For this double replacement reaction, I'm going to keep phosphoric acid together. All right? Calcium chloride, is that going to break up or stay together? It's going to break up because here is the rule for chloride, bromide, iodide, soluble, except next to one of these, calcium is not included in that list, so it's going to break up. Now, when it breaks up, I have 3 calcium and 6 Cl. Because when everything breaks up, I have 3 calcium and I have 6 Cl. Do not forget, when you break it up, they break up into ions. That really, really, really matters. They have to break up into ions. It doesn't become calcium mellow. No, it becomes calcium ion. So water is going to break it up into ions. All right, so far so good. Now next part. I have hydrochloric acid. Is an acid? So I don't look at the solubility rules. Strong acid or weak acid? This is a strong acid. So this is going to completely break up in water. So I break it up into 6H plus and 6Cl minus because I have 6 hydrochloric acid. When everything breaks up, I have 6H plus and I have 6Cl minus. Calcium phosphate, is that going to break up or not break up? Let's go over here. No rules for calcium. We have a rule for phosphate. Carbonate, phosphate, silicate, sulfides, and chromates. They're insoluble except if it's next to one of these. Next to one of these is going to make it to be soluble. Calcium is not in a 1A group, so this is going to be insoluble. It was not next to one of those that would make it soluble. Because the bottom part of the solubility rules is different, right? Because they're insoluble. If it's next to this, they make it soluble. But calcium is not in a 1A group and it's not ammonium. So far, so good. Okay, what do we call this? We call this total ionic equation. Now, we're going to cross out the spectator ions. They look exactly the same on both sides. What are the spectator ions? Cl. They look exactly the same on both sides, and that's pretty much it. Okay, I'm going to write the total ionic equation. It would be 2 phosphoric acid. Now remember, well, in a second I'll do it. And then 3 calcium plus 2 goes to 6 H plus calcium phosphate. Now, don't forget the charges are all good. Now and this is a net ionic equation. And I said, you don't have to worry about the phases until the net ionic equation. Once you get to the net ionic equation, then I do want you to put the phases that are in because that does matter. So if I come over here, I know this is AQ because AQ means dissolve in water. I know this is AQ, right? And I know this is solid. How about phosphoric acid? What is phosphoric acid? Remember, all acids are soluble in water. So all acids will get AQ. So all acids would get AQ because all acids are soluble in water. Acid exists in water. It's just that weak acid, we're going to keep them together. Strong acid, we're going to break them up. Because remember, some of the phosphoric acid will break up. It's just not enough for us to make that, so we're going to keep it together. So all acids get AQ because all acids are dissolved in water. But strong acid, it completely break up. Weak acid, only a few breaks up, so we are going to keep it together. So far, so good? Okay. Now, what type of double replacement reaction is this? What do I form at the end? I form a precipitate. So this is a PPT reaction because I formed a precipitate at the end. So far, so good? All right. So this was a big one. This was a big one. I give you another one to do. I usually give you the hard ones to take home. This one I like because I'm also testing to make sure that you know how to write the formulas. So this one is lead 4 nitrite. So lead is Pb, nitrite is NO2. Hopefully you're learning the polyatomic ions. Now, if you look at this one, Pb, I told you, has a +4 charge. Nitrite polyatomic ion has a -1 charge. So if I cross multiply the charges, I get Pb NO2 4. You guys are good with that? Okay. Plus sulfuric acid. Sulfuric acid. Every time you end with the name acid, what are you going to write down? You're going to write down H at the beginning. Acid means you have H at the beginning. Sulfuric acid means it used to be 8. Go back to the rules. 8 becomes ek, 8 becomes us, right? And then there's no hydro because there's no hydro, so we don't look at the periodic table. Usually when you have ric acid or us acid, is a polyatomic ion. So sulfuric acid used to be sulfate. Used to be sulfate. Sulfate is what? Is SO4. Okay, again, it's an acid. Sulfuric acid, so I know it's an acid. I want to put a hydrogen. And is ic acid, used to be 8, so it used to be sulfate. Now again, remember, acids and bases are ionic compound. You have to rebalance the charges. The charge on hydrogen is +1. Sulfate, polyatomic ion, is -1. So I have to cross multiply the charges. If I do that, I get H2SO4. That was a little good review, what we talked about for running ionic compound. Alright, so now we're going to do the double replacement reaction. We're going to go inis with inis and outis with outis, right? Now we're going to do a double replacement reaction. Inis with inis, outis with outis. Now Pb is going to leave nitrite. Is going to go and hang out with sulfate. So I'm going to go to the other side. I want to write the Pb first because you write the metal first, the cation, and then the non-metal, which is SO4. Okay. Now, we know the charge on Pb is +4 and sulfate is -2. You guys are good so far? This is a little tricky one. Oh, I'm kind of liking myself for doing this. So we're going to cross multiply the charges, right? Sometimes I get impressed by my questions. So we're going to cross multiply the charges. If we cross multiply the charges, what do you get? Pb2 SO4 4. You guys agree? But what do you have to do? If you could, after you cross multiply the charges, you should simplify if you could simplify. Could you simplify in this case? Yes, you could divide it by 2, right? And you should divide it by 2. So if you could simplify, you must simplify. Next, we have to divide this by 2, right? So we would have to divide this by 2. So if we do that, what we end up getting is Pb SO4 2. You guys are following me so far? We will get Pb SO4 2. Because again, I must simplify. If I could simplify, I can simplify by dividing this by 2. Okay? So you cross multiply the charges, and then you simplify if you could simplify the subscript. Okay? Again, you don't mess with this because this is a polyatomic ion. This is how it exists. Alright, plus, now what is my inis? My inis is nitrite is going to go and hang out with H. Nitrite is going to go and hang out with H. I'm going to write the H first because the H is my cation. And then I'm going to write down the NO2 after that. The charge on H is +1. Nitrite is -1. This is already balanced. This was a hard one. So what I get here is Pb4 nitrite plus sulfuric acid goes to Pb4 sulfate plus nitrous acid. You guys good with this so far? The hardest part was probably here. After you cross multiply the charges, don't forget to simplify. You must simplify if you could simplify. Now we have to balance the entire equation. Is the entire equation balanced? Not really. 1 PB, 4 nitrite, 1 nitrite. So I'm going to add a 4 over here. So now I have 4 nitrite over here. I have 4 hydrogen now. So I'm going to add a 2 over here. So 4 hydrogen, 2 sulfate, and 2 sulfate. This was a hard one, but you guys got this. Now we have to look at the solubility rules to see what happens to each one in water. What happens to this one? Lead for nitrite. Nitrate, nitrite, acetate, chloride, iodide, all soluble, no exception. So that one is going to break up into ions. Don't forget the ion part. It breaks up into ions. If it breaks up, I end up having 4 NO2 minus 1. I end up having 4 of those. Now, phosphoric acid, do not look at the solubility rules for acid. Is it a strong acid or weak acid? This is a strong acid. So what does that mean? A strong acid is going to completely break up into ions. When you break it up, you end up with 4H plus and 2 sulfate. Because 4H plus and 2 sulfate. Because you have 2 sulfuric acid. Each one has 2 H plus. So you end up at the end with 4H plus and 2 sulfate. Alright, let's come over here. How about this one? Lead for sulfate. Would that break up or not break up? So we don't have a rule for lead. We have a rule for sulfate. So here sulfates are soluble except next to copper 1, silver 1, gold 1, mercury 1, Pb plus 2, barium plus 2, Sr plus 2, Ra plus 2. So sulfates are soluble, but if they're next to Pb plus 2, they're not soluble, okay? So if they're next to Pb plus 2, they're not soluble. But what Pb do we have here? Here we have Pb plus 4. And when you look at this, you might get tempted to say, oh, the 2 comes from here. But this is a little tricky because it was plus 4 and plus 2, and we simplified it. So this is actually Pb plus 4. So this is soluble. So this is Pb plus 4, it's soluble. Pb plus 2 would have not been soluble, but this is Pb plus 4. I know this is a little hard, but hard is good. So Pb plus 4 is going to be soluble. So what am I going to do? So it's going to break up into ions. It's going to break up into Pb plus 4, and I have 2 sulfate. Okay. Now the last one is an acid. This is an acid, right? The last one, this is an acid, okay? Is that acid going to break up or not break up? Nitrous acid, weak acid or strong acid? Nitric acid is a strong acid, but not nitrous acid. So that one is a weak acid. What does that mean? We're going to keep it together. We are going to keep it together. Yeah? All right, beautiful so far. Okay, now my spectator ion. What are my spectator ion? I have only one. 2 sulfate, 2 sulfate. I can cross them out. No, Pb. I can cross this one out also. Yeah? Okay. Now, let's finish this up. So I have 4 NO2 minus dissolve in water. So I'm going to add a AQ to it. Is going to be AQ plus 4H plus dissolve in water, AQ goes to 4HNO2, but also AQ, because we said all acids are going to get AQ because all acids are soluble. Just a weak acid, we're going to keep them together because they don't fully dissociate. So that would be my net ionic equation. My net ionic equation. Okay, this was a big one. All right. Nice job. Next week, we're going to start talking about redox reaction. All right, I'll see you guys next time.